Okay, welcome back, kiddos. Now we are moving on to Unit 5, and we're talking about triangles. So you know a little bit about triangles already, I know. We know that they have three sides, right? So all these have three sides, but we're going to talk about how we can classify those, and we're going to try to graph those and think about the relationships. And then we're going to talk about the exterior angle theorem and how we can calculate that. So that being said, let us get right into it. So triangles can be classified by their blank and their blank. What do you think? By their angle measures, and their side lengths. Okay, so I'm sure you've heard most of these terms before, but we're going to go into more in depth and a better application of it today. All right, so first off, a right triangle. Okay, so right triangle, that's the key word on there is right. Okay, that's when one angle equals 90. Okay, so on this one right over here, that angle right over there is 90 degrees, and we see that box there. That's the hint that it's a right triangle. Okay, next we have an obtuse triangle. Okay, obtuse means one angle is greater than 90. Okay, so if we see this right over here, right, hopefully you recognize this, right? On a right triangle, right, it looks just like this, right? It makes a sharp right turn, right, which is 90 degrees, right? So what we know about this one right over here, this is larger than 90 degrees, right? So this one is an obtuse triangle, okay, because one angle is larger than 90. All right, so then you probably remember then this last one as far as these three. All right, so this one is when all angle measures are less than 90, right? We see this angle measure right over here, right? And then we see this angle measure right over here and this one right over here. And I'm going to put different arcs on them, right? That's one arc, that's three arcs, and that's two arcs. That shows that these three are different angle measures. Okay, so acute is when all are less than 90. Okay, and then the last one, equiangular, right? And so we should think about that keyword equa means equal, right? Equal angles. Okay, so when they're all equal angles, there are three congruent angles, right? Which we know congruent means equal measure, right? So if they're equal measure, they all have to be 60 degrees, right? So this one would have to be 60 degrees, this one would have to be 60 degrees, and this one would have to be 60 degrees. Okay, so one other thing that we know is that when they are equal angles, they are also equal sides, right? So we'll talk about that in just a moment as well. So that's also an equal angle one. It's also going to be equilateral. All right, so those are on the angles. So we're going to use that first to classify a triangle. Okay, and then the second way is by their side lengths. Okay, so by their side lengths. And so that's what we're going to talk about right now. So the first one is a scalene triangle. Scalene means no congruent sides. So these three sides right here look like they're all different, but we want to confirm that by marking them, right? We'll say that has one tick mark. Okay, that one has two. Okay, and we'll say then that one has three. Okay, that tells us that this one is different from that one and is different from that one. Okay, so no congruent sides. All right, next we're going to talk about an isosceles. An isosceles has two congruent sides, right? So if we see right over there, that side right over there and that side right over there are congruent, right? We could say this one right here and this one right here are congruent sides. And one way we can remember it is like eyes, we can think like we have two eyes. So two sides are the same. Okay, so isosceles means two sides are the same length. Okay, scalene means no sides are the same. And then equilateral, okay, we might think from that lateral, that means equal. Lateral means sides. Okay, so equal sides. So three congruent sides, right? And we know that congruent means equal measure. All right, so that's why we are showing that this side right over here has 2, right? This side right over here has 2, right? This side right over here has 2. So that confirms for us that this side is equal to this side is equal to that side because it's equilateral. Okay, so keeping that in mind, that's how we're going to classify all triangles. They are either going to be they're going to be one of these and one of these. So we can say we're going to choose from column number 1 and column number 2. So it has to be one of these and one of those both. All right, so let's talk about this one right over here. So this is one you might see on the DCP. It says classify the triangle by its sides and angles, right? And they want to know if it's a right triangle or not. This one looks like a right triangle. Let's first see if it's a right triangle. If it's a right triangle, that means that the slopes must be perpendicular, right? Which means opposite reciprocals, right? Reciprocals, right? They must be opposite reciprocals. So let's check that out, right? Let's check the slope out of this line and this line to see if we can put a box there, right? So let's look at this one right over here first. So this one right here, that goes from P to O, right? So let's just write over here the slope of PO. Let's calculate that. So let's say we can say the slope of PO, right? That's going to be equal to, now we can use our slope formula, right, with this, or we can just count those. So, right, imagine I drew a slope triangle, right? So if I do a slope triangle like that, then I could calculate those rise over run, right? So we know it's rise over run, right? So I could say it goes down 2, right? So down 2 is going to be negative 2, and then 1 to the right. So 1 to the right. So that's the slope of PO, right? Well, then what if I said the slope of this one right over here, right? So that would be OQ, right? So the slope of OQ, if we said that's going to be rise over run, right? Let's calculate that. So let's just make a slope triangle, right? So just like that, and let's calculate those. So rise would be 1, 2, 3. So since we're going down, let's just call that negative 3, right? Negative 3, right? And then from that corner, though, we're going to go to the left. So I'm going to say 1, 2, 3, 4, 5, 6, right? So since I'm going to the left, I'm going to say that's negative. So that reduces into positive 1/2, right? So I'm just going to circle these now, and I'm going to start circling when we're not quite done. But it's the information that we need, and we'll box our answer, right? So what are these slopes? If they are perpendicular, then they must be opposite reciprocal. So what do we know about negative 2 over 1 and 1 over 2? Negative 2 over 1 and positive 1 over 2 are opposite reciprocals. So the slopes are opposite reciprocals, so it's a right triangle. All right, so we know that we can do this right over here now because we did this, right? So the right angle is going to be angle O, right? We could say that's angle O, or we could say angle POQ, right? Angle POQ. All right, so now that we know that, let's talk about how we can classify the sides, right? So the side lengths, what do we know about the lengths? We have to know whether they are 3 congruent sides, or if all the sides are different, right? Or if there's 2 sides are different. Well, how do we know? Okay, well, if we need to find the side lengths, we're going to use the distance formula, right? We're going to use that distance formula. So let's go ahead and set that up. Remember, on that distance formula, we're going to start setting it up with, let's just put it right over here, right? We're going to say x2 minus x1, close it, squared, plus y2 minus y1, close it, squared, right? So let's start with this. I'm going to start with the blank Okay, so if we do that, sometimes it's easier if we remember, but it's okay if you don't want to do it that way. All right, so OP. So let's look at those 2 points, O and P. Okay, and we're going to remember that X comes first, then Y, right? X is first, then Y. So we're going to keep that in mind. So O and P. So X minus X. So 0 minus -1, right? 0 minus -1. So we're not going to goof that up. We know it's a double negative. Then the y values, right, from O and P. So y value of O is 0. Y value of P is 2. So 0 minus 2. Okay? Now, let's just, if I put that into the Desmos, if I just, now this is something different uh, for a upcoming lesson. I'm just typing in the stuff that's on the inside. If I did that, that would give me the square root of 5. Okay, so we're going to be working with square roots here in just a moment, very soon. So I want to start with that. All right, so next, O and Q. So we remember X is going the first one. X is the first number. So let's look at O and Q. The X value of O is 0. X value of Q is 6. So we're going to say 0 and 6. So 0 minus 6, close it squared, plus, right? And then the y value of O and Q. We remember O, the y is the second one. So O and Q, right? O and Q. So O would be 0, as again, and Q would be 3. So 0 minus 3. Okay, so if we put that into our calculator, once again, that would be the square root of 45. Okay, so now let's set it up that third way again. So remember, if you want to do that, subtract in the middle, right? So whatever is easiest for you. Okay, so if we did that, then PQ, right? P and Q. So we're going to go from P to Q. Remember, we're going to use the X values in the first one, Y is in the second. X is the first one, so X minus X. So the first one from P and Q. So -1 and 6, right? -1 and 6. Okay, then P and Q, the Y value. P, so 2 and 3, right? 2 and 3. Okay, so once again, remember I'm talking about only putting in the inside part, right? So if we only put in that inside part, right, not the whole thing, that would give us the square root of 50. Okay, so what do we know? All three side lengths are different. That tells us it's scalene, right? Scalene and right. And so now we're going to box our answer. So that tells us our final answer is scalene right. It's a scalene right. Because all side lengths are different, that tells us scalene, and we found out it's a right triangle because these two cross at opposite reciprocals. All right, so that being said, let's go ahead and get into some Delta Math practice. So let's take a look at this one right over here. This is how it's going to look right on your Delta Math screen. So let's get to it. All right, so remember, the first thing we're going to do is we're going to look at the sides. We said the angles first, right? So first thing we're going to do is look at the angles. Okay, and then the second thing we're going to do is look at the sides. Okay, so first thing, angles. What do we know about the angles? We got 39, 39, and 102. 39, 39, and 102. So that is definitely not a right triangle, right? Because we don't see 90 degrees. So we don't know that that's definitely wrong. This is greater than 90, right? This is greater than 90 degrees, right? So if it's greater than 90, we know it has to be obtuse. So that could be correct. That's wrong. That's wrong. That's wrong. That's wrong, right? So at least we can, now we said it has to be either scalene or isosceles. So which one do you think is correct, scalene or isosceles? Scalene means no sides are the same. Isosceles means two sides are the same. So this one and this one tells us that it is isosceles because two sides are the same. Okay, so isosceles obtuse is our correct answer. All right, so let's keep it moving. All right, see if you can get this one on your own. Pause this one, see if you can get this one. All right, so we said the first thing we're going to do is we're going to look at the angles, right? So what do we know? This one's 60, this one's 60, this one's 60. They're all the same, right? All three the same. So that means it can't be acute, can't be obtuse, well, it can't be obtuse and it can't be right, right? Because we know they're not, that's not less than 90 and it's not a right, right? So we know it's not obtuse, it's not right. So now, you may already know what it is, but let's see the sides, right? So this side and this side and this side, all three sides are the same. So that means it's not isosceles because isosceles is just two sides. Scaling means none, so it has to be equilateral, right? Because we said equilateral also means equal sides. All right, let's keep it moving. Hopefully you got that one on your own. All right, keep it going to this one right over here on the bottom left. We'll get it here. All right, bottom left. So what do we know? First thing we're going to do is look at the angles, right? So what do we know about the angles? Angles, we got 114, we got 29, and 37. So that tells us that it is obtuse, right? So we know right can't be right, that can't be right, okay? And we know it can't be equilateral also because that's also equal angles anyways, right? So obtuse, because of this, right? That tells us it's obtuse at least. Sorry, let's not do that. This tells us it's obtuse, right? Okay, so then what do we know about the sides? We got 4.7, 5.77, and 8.82. So it can't be isosceles, right? And that was the only other one. And it is scaling, right? Because three sides are different. All three sides are different, right? So it is scaling. All right, so hopefully you're finding that easy. Let's get to this last one, and then you can start some practice on this. All right, so the first thing you said, we want to do the angles first, right? So the angles, we see 45, 45, and 90, right? So what can we put here? Instead of doing the arc, what should we put there for the 90? We should put a box right there because it's 90 degrees. So if it's 90 degrees, we know it's a right triangle, right? So it can't be that, can't be equilateral, can't be obtuse, right? It might be scaling, right? Or it might be isosceles. Let's look at the side. So we got 5.97, 5.97, 8.44. So this side and this side are the same. It has to be isosceles. Right, that's very good. All right, so let's go ahead and do the practice right now on your Delta math that you have for these right here. Go ahead and practice those, and then let's go on to the second page. All right, so now on the second page, we can get through this quite quickly as well. All right, so the three interior angles of a triangle always add up to 180. So 3 always add to 180. You probably already know that one. So let's look at this right here. So if we know this one, if we know this angle is 45, this is 33, and this is x, how do we find x? Well, let's set up what we know. We said that 1, 2, 3 has to add up to 180. So let's do that. The first one, right, plus the second one, plus the third one, right? So now we just follow our steps, right? So the first step we always try to do is combine like terms, right? So we see this right over here, I see a 45 and I see a 33, and I can combine those, right? That total of 78. So I can just go and write down that 78 right over there. Okay, I can just cancel those out. And since I know it's a positive 78, I can write that there. And then I just have to bring down this positive 1x, right? And I know it's a 1x, so I can just write 1x right over there equals that 180. Right? So if it's helpful, draw our line down. Right? And then our second step, move the terms to the other side. So we're going to move by adding the opposite, right? Adding the opposite. So what do we want to move? Do we want to move the 1x or the 78? Well, we know we're going to divide at the end with this, right? So if we're going to do that last, that means we need to do that next, right? By adding the opposites. The opposite of positive 78 is negative 78, right? You can do that over there. Going to do that over there. That cancels out. Going to bring down our 1x equals 102, right? Now we could divide by 1, right? But if I divide by 1, I know my answer is still going to be x equals 102. All right, so I'm going to box my answer on that, and that way I have my final answer. So it's as simple as that on this practice. We just need to know that they all add up to 108. All right, so next, think if you can get this one on your own. This is a little trickier. All right, well, what do we know? We have three angles. That's x, this, and then what's this? That tells us that this one is 90 degrees. That's right. Well, if we're trying to find x, we know they all add up to 180, right? So we're going to say the first one, right, plus the second one, which is x, plus the third one, which is 90, right? So we're not going to miss this last 91 right there, right? So it's a common mistake to miss that one. All right, so first step, we want to combine our like terms, right? So we have 48 and positive 90. If we put that into our calculator, that's going to give us 138, right? And that's a positive 138. So I can cash that out, right? And then I know I'm going to just bring down my 1x, right? Because I'm going to put a 1 over there if it's helpful for me, right? Then I'm going to equal 180. Now we're just going to add the opposite, right? I know I'm going to work with the x last, so I'm going to divide, subtract that 138, subtract 138, right? Cancels out. 1x equals 138 minus, coming from 180 gives us 42, right? So that means x is going to be 242 degrees as well. All right, so on this practice, we are just remembering that it equals 180. All right, so now stepping up, this is for the ones that are going to push ourselves right now to see if we can get this on our own before we can go over this. You know how to do this, and then I'll show you. All right, so this one. Now, one thing trickier, in case you did the math but you didn't recognize this, is just find the measure of the smallest angle. Okay, so this is key right over here, the smallest angle as well. Well, what do we know? We know we have 1, 2, 3 angles, right? This one's measured by 2x plus 7. That one's 6x plus 3. This one is 90 degrees, right? Well, if we're trying to find the smallest angle, we need to solve for x, right? So that tells us we need to make an equation. Well, what do we know? The only thing we know about angles is that they all add up to 180, right? And we know we have 1, 2, 3 angles. So let's go and write that down. The first angle, I'm going to say is 90, right? That's the first one. Plus the second one, I'm going to say is 2x plus 7, right? Plus that third one, we're going to say is 6x plus 3, right? So now let's just go and combine. I got 90, I got plus 7, and I got plus 3. Right? I can put all three of those in my calculator. If I do that, that's going to give me 100. Okay, so then I can just cancel those out. Right? Then I know I can put 2x and plus 6x, I can combine into plus 8x, right? Equals 180. Okay, so now we may be confused. What do we do next? We know we're going to work with that last, right? So if we're going to do that last, that means I need to do that next by adding the opposite. The opposite of 100 is negative 100, right? Going to subtract 100 from both sides, cancels out. 8x equals 80, right? You may already know the answer to this one as I'm talking to you, right? I divide by 8s right there, so x equals 10. Now I'm going to circle this because that's not our final answer, because they want the smallest angle. So now we need to substitute for x, right? That's our second step. Second step is we need to substitute for x. So if we do that, then let's do that right over here. So this one we're going to say 2x plus 7, and that's going to be the same thing as 2 times 10 plus 7, and that's going to equal 27, right? And then this one right here is going to be 6x plus 3, which is 6 times 10 plus 3, which is equal to 63. So that means the smallest one is this one right here. Okay, so that's our smallest angle measure, 27 degrees. All right, so on this one, it's a little bit tricky. You're going to have to recognize that before you type it into the calculator. All right, so keeping that in mind, let's go ahead and do that practice on Delta Math on this before we move on to our last one. All right, so I know the video's a little long, but we're going to get through this, and the calculations are easy. So the last one, exterior angle theorem. So what this says is the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Wow, that's tricky. The exterior angle of a triangle is equal to the sum of the two opposite interior angles. So if I know the measurement of this one and this one, okay, I'm going to say those are the two opposite interior, right? Opposite meaning not with it, right? It's on the opposite side. So these two are equal to this exterior angle. And how this is created is, imagine I just drew a line over here, right? This exterior angle is right over here. Okay, so this one is going to be equal to those two added. Okay, so keeping that in mind, this is another diagram of that. Okay, so if I say angle A and angle B, right? If I add angle A and angle B, it's going to be equal to this one right over here. Angle 1. All right, so keeping that in mind, let's get right into some practice. So on this one, they need to solve for x, right? So if we're going to think about solving for x, we're going to use the exterior angle theorem, right? So to do that, we're going to say this plus this, right? X plus 112 equals the opposite one, right? Because it's not this angle, it's the opposite. So this one and this one equal this one. So we can say x plus 112 equals 129, right? So then we're just going to subtract 112. So as long as we understand that x relationship, then that's our solving procedure. So that's as simple as it is. X is 17 because this is equal to these opposite. Okay? So these two are opposite angles. All right, from that. All right, so next, let's look at this one. So see if you can get this one on your own. It's the next level. All right, well, what do we know? We know that this one right over here, right? This angle right over here is how much? This is 90 degrees, right? We're not going to get tricked by that. That's 90 degrees. That's x. These are opposites, right? Opposite angles. Opposite from this, right? So we can say that x plus 90 is equal to 127, right? So then we just subtract 90. Okay, so that means x equals 37 degrees. That's right, 37 degrees. All right, so now we're getting on to the last one. So let's do this. And this is stepping it up. So this is the toughest one. It's not that tough. See if you can get this one on your own. All right, so I'm going to show you the most common wrong way. The wrong way is this, to say that x plus 50 equals 70. And why is that? If we said that x plus 50 is 70, it's because these are not opposite angles. Right? If you look at this, this is a linear pair. Right? So these two make a linear pair. So those are supplementary. What does supplementary mean? That means they add to 180. Right? So that's what we want to think about on this one. So on this one, we're going to say that x plus 70 equals 180. Right? X plus 70 equals 180. So if we subtract 70, that means x equals 110. All right, so that's a little bit tougher, but that's not too tough. Right? So we're going to have to recognize that between these. So a common mistake would be to just blindly say that these two add up. But if you look at this one and this one, they're opposite from here. They're not along with it. This one is a linear pair. All right, so you got these, folks. If you have any questions, just let me know.